Assalamualaikum and very good morning to our lecturer. We are Group 1 and today we would like to present our assignment for MKW3003, Probability Theory in Finance. First, let me introduce myself. My name is Nuri Hamani binti Biharam and my matrix number is S81669. Now, I will present Task 1, Question 1. First, let me read the questions. A stock is currently priced at 100 over one period. The stock price can either move up by a factor of 1.20, move down by a factor of 0.85. The probability of an upward movement is 0.6. Based on this information, we are required to calculate the expected logarithmic return, the variance of logarithmic return, the expected payoff of a binary options, and the variance of the options payoff. First, I will calculate the expected logarithmic return. The formula used is E of y equals p times ln of u plus 1 minus p times ln of d. For the upward movement, I calculate the natural logarithm of 1.20, which gives 0.1823. For downward movement, I calculate the natural logarithm of 0.85, which gives negative 1625. Next, I multiply 0.1823 by 0.6, giving 0.1094. Then I multiply negative 0.1625 by 0.4, giving negative 0.0650. Finally, I add both values together to obtain 0.0444. Therefore, the expected logarithmic return is 0.0444 or approximately 4.44%. Next, I calculate the variance of logarithmic return. The formula of variance of y equals E of y square minus the square of E of y. First, I square both logarithmic return and multiply each by its probability. After adding both values, I obtain E of y square equals to 0.03059. Then I square the expected logarithmic return, which is 0.0444 square, and subtract it from 0.03059. This gives a variance of 0.02862. Next, I calculate the expected payoff of the digital binary option. The option pays at 100 if the stock price move up and 0.100 if move down. Multiply 100 by 0.6, which equals 60, and I multiply 0 by 0.4, which remains 0. Ending both value give an expected payoff of 16 ringgit. Finally, I calculate the variance of the option payoff. First, I square 100 giving 10,000 and multiply it by 0.6, which equals 6,000. Then I subtract the square of the expected payoff, which is 60 square or 3,600. Therefore, the variance of the option payoff is 2,400. In conclusion, the expected logarithmic return is 0.044. The variance of the logarithmic return is 0.02862. The payoff is 16 ringgit, and the variance of the option payoff is 2,400. That's all for my presentations. Thank you for your attention. I will now pass to the next presenter.
Hi, Assalamualaikum. My name is Nur Amalina binti Muhammad Swaini. My matric number is S81818 and I will explain about second problem, which is the portfolio risk normal distribution problem. For this portfolio, the expected annual return or mean is 8%, while the standard deviation is 15%. Since the returns are assumed to follow a normal distribution, we apply the empirical rule. According to this rule, around 67% of all possible returns are expected to fall within one standard deviation from the mean, while about 95% fall within two standard deviations from the mean. This helps investors to estimate the range of likely returns and understand to the portfolio's level of risk. Next, we calculate the 67% interval using the formula mean plus or minus one standard deviation, which is 8% plus minus 15%. The lower bound is 8% minus 15%, giving negative 7%, while the upper bound is 8% plus 15%, giving 23%. Therefore, we can conclude that approximately 67% of the portfolio's annual return are expected to fall between negative 7% and 23%. This means there is a high probability that the portfolio returns will stay within this range under normal market conditions. Now, we determine the 95% interval by applying the empirical rule using the formula mean plus or minus 2 standard deviations, or mean plus minus 2 sigma. Since the mean return is 8% and the standard deviation is 15%, 2 standard deviation equal 30%. Therefore, we calculate 8% plus minus 30%. The lower bound is 8% minus 30%, which equals negative 22%, while the upper bound is 8% plus 30%, which equals 38%. This means that approximately 95% of the portfolio's annual returns are expected to fall between negative 22% and 38%. In other words, there is only about a 5% chance that the portfolio's return will fall outside this range, making it a useful measure for assessing the portfolio's overall investment risk. So, compared to the 67% interval, the 95% interval covers a wider range of possible returns, giving investors a more comprehensive view of both potential gains and potential loss.
Hello, my name is Nur Adlina Afifah binti Mama Ali. My metric number is S81831.
Now, I will discuss why a perfect Gaussian world may underestimate risk in financial market. The Gaussian or normal distribution assume that extreme market events are very rare and have a very low probability of occurring. Under this assumption, most returns are expected to remain close to the average return, while very large gains or losses are considered unusual events. However, real financial markets do not always behave according to this assumption. In practice, extreme market movement occur more frequently than what the normal distribution predicts. Financial markets are influenced by many unexpected factors such as economic crisis, political instability, change in investor sentiment, and global events. Another important concept is known as factors. Factors mean that the probability of experiencing extremely large gains or losses is higher than what is suggested by a normal distribution. As a result, investors may face risks that are much greater than expected when relying only on a Gaussian model. A good example is the global financial crisis of 2008. During this period, stock markets around the world experienced several losses and sharp decline. These losses were significantly large and occurred more frequently than what would normally be expected under a perfect Gaussian distribution. Therefore, although the Gaussian model is useful for estimating average market behavior and everyday risk, it may not accurately capture extreme events. As a result, relying solely on this model can lead to an underestimation of the true level of market risk. That's all from me. I will pass to my friends. Thank you.
Hi, my name is Nur Safana Ilmi binti Farus Abadi and my ID student is S81494. Today I will explain the microstructure asset pricing problem using the Poisson distribution. In this problem, a high-frequency trading firm models the arrival of buy market orders. The average arrival rate is given as lambda equals 4 orders per millisecond. For a Poisson distribution, the expected value is equal to lambda. Since lambda is 4, the expected value is also 4. This means that, on average, the firm expects to receive 4 buy orders in every millisecond. Next, the variance of Poisson distribution is also equal to lambda. Therefore, the variance is 4. This shows that the spread of variation in the number of buy order arrivals per millisecond is 4. Now, we calculate the probability that the firm receives exactly 2 buy orders in 1 millisecond. The Poisson probability formula is P of x equals x is equal to e to the power of negative lambda multiplied by lambda to the power of x divided by x factorial. Here lambda is 4 and x is 2. So we substitute the values into the formula. P of x equals to is equal to e to the power of negative 4 multiplied by 4 squared divided by 2 factorial. The value of e to the power of negative 4 is approximately 0.018315. Then 4 squared is 16 and 2 factorial is 2. So the calculation becomes 0.018315 multiplied by 16 divided by 2. This gives us 0.1465. Therefore, the probability that the firm receives exactly 2 buy orders in 1 millisecond is 0.1465 or 14.65%. In conclusion, the expected value is 4, the variance is 4, and probability of receiving exactly 2 buy orders in millisecond is 14.65%.
Now we move to the task 2, which is the live computational demonstration and pitch digital skill at 3. So from this task, our group chose to make a Excel spreadsheet to give the solution from the 3 answers. So for the first question, we have to find the expected logarithmic return and the variance of the logarithmic return. So from the screen right now, we have to enter the value for the current price SO, the value of U, D, and probability of upward move P, and also option payoff in the table below. So for the first table, we have the SO, which is 100, U 1.2, D 0.85, and P 0.6. So at the output, we get the stock price up, which is 120. So this is common. Stock price down 85. So this is the common. And also we also get the lot return up, which is this is common, and lot return down. This is the common. And also for the answer, we get the expected lot return, which is 0.044. And this is the common, and also the variance lot return, which is 0.02853. This is the command that I use. Okay. Then we also have to find the expected payoff and the variance payoff. So I made the second table, which is the option payoff, and from the answer we have to enter the value of 100. And also for the expected payoff, we get answer which is 60 from this command, and also variance payoff we get 2400 for the variance payoff, and I use this command. So we move to the next question, which is to find the portfolio risk normal distribution problem. So from this question, we get the information about the expected annual return, which is 8%, and standard deviation, which is 50%. So the question wants us to find the approximate interval within 67% and 95% of the portfolio annual return outcome we found. So from the screen right now, we have to enter the value for mean, return, and standard deviation. So for the mean return, we get the 0.08 and standard deviation 0.15. So after that, we get the output for the lower limit, which is negative 0.07, and the upper limit, which is 0.23. So for the approximate interval for 95%, we get the lower limit is negative 0.22 and upper limit is 0.38. Okay, and then we make it to the sentence. So we get the 67 approximate interval of the portfolio annual return outcome is negative 0.07 to 0.23. And then for the 95% approximate interval of the portfolio annual return outcome is negative 0.22 to 0.38. So for the last question, we have to find the microstructure asset pricing problem. So the question is about a high frequency trading firm model the arrival of buy market orders using a Poisson distribution. The average arrival rate of buy order is lambda equal to 4 orders per millisecond. So the question wants us to find the expected value and the variance of order arrivals per millisecond for this asset. So at the screen right now, we have to enter the value for average arrival rate of buy orders, which is lambda, and the value of x in the table below. So from the equation, we get the lambda equal to 4 and x equal to 2. So from this table, we automatically can get the expected value of order arrival equal to 4, and the variance value of order arrival also give the same answer, which is 4. And then the last task from the question is about to find the exact probability that the firm receives exactly 2 buy orders in each millisecond. So we have to find the probability for x equal to, and then by using the Poisson command here, if you look at this, and then I get the 0.1465 for this answer.
That's all from our group. Thank you.